Through Canada, 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 the second largest country in the world, is a vast expanse of natural beauty, cultural heritage, and untapped secrets spanning nearly 10 million square kilometers. This land of rugged mountains, endless forests, and shimmering lakes is known for its breathtaking landscapes and multicultural cities. From the majestic Rocky Mountains in the west to the historic coastlines of the east, Canada holds stories of ancient civilizations, unique ecosystems, and recent discoveries that continue to captivate explorers and scientists alike. Have you ever wondered what secrets lie hidden beneath Canada's sprawling landscapes and beneath its icy waters? Imagine lost Viking settlements, dinosaur fossils from millions of years ago, new species thriving in some of the world's harshest environments, and geological wonders that reveal Earth's dynamic past. Join us as we delve into Canada's recent discoveries and unveil the hidden marvels of the Great White North. Ancient Viking settlement discovery in Newfoundland. In 2023, archaeologists made a groundbreaking discovery in Newfoundland, an ancient Viking settlement site that predates the well-known site at L'Anse-aux Meadows by several decades. This newly discovered site, situated along a rugged and wind-swept coastline, adds further weight to the theory that Norse exploration of North America was more widespread and sustained than previously believed. Using cutting-edge remote sensing technologies such as LiDAR, light detection and ranging, and ground-penetrating radar, researchers identified subsurface anomalies consistent with Viking-era structures. Subsequent excavations revealed the remains of longhouses, hearths, and even fragments of clinker-built boats, a signature construction style of the Vikings. The architecture and artifacts unearthed at the site are remarkably similar to those found in Norse settlements in Greenland and Iceland. The longhouses, characterized by their elongated rectangular shapes and turf walls, suggest a community that may have engaged in resource exploitation such as timber harvesting, fishing, and possibly trading with indigenous peoples. Among the artifacts were iron nails, rivets, bone needles, whetstones, and shards of pottery, all indicative of Norse craftsmanship and daily life. Additionally, the discovery of a large ironworking area hints at the possibility of metal production and ship repair activities, further supporting the idea that this was not a temporary encampment, but a semi-permanent settlement. Radiocarbon dating of organic materials such as wood and charcoal places the settlement's occupation around 990 to 1020 AD, aligning with the time frame of the Vinland sagas, which describe Viking voyages to a rich, fertile land across the Atlantic. The discovery also raises questions about the extent of Viking navigation and whether they ventured further south along the eastern seaboard or established other outposts along the North American coast. This finding is significant because it challenges the notion that L'Anse-aux Meadows was an isolated attempt at colonization. Instead, it supports the theory of multiple exploratory missions or even a network of settlements stretching across the Atlantic. Researchers believe that additional sites may be hidden beneath peat bogs, dense forests, or eroded coastlines, waiting to be uncovered. Advanced techniques like laser scanning, isotopic analysis, and ancient DNA studies are likely to play crucial roles in identifying and interpreting these sites. Could this new discovery finally reveal the full scope of Viking exploration in North America? With continued archaeological investigation and collaboration with indigenous communities, the true extent of Norse presence in the New World may soon become clearer, offering a richer, more nuanced understanding of early transatlantic history. Frozen in time. Ice Age fossils in the Yukon. In early 2024, miners working in the Yukon's Klondike region made an astonishing discovery, a rich trove of Ice Age fossils that included the remains of woolly mammoths, steppe bison, ancient horses, and dire wolves. These specimens, remarkably preserved in the region's permafrost for over 20,000 years, provide scientists with a rare and detailed glimpse into the prehistoric ecosystems that thrived during the Pleistocene epoch. The cold, stable conditions of the permafrost have kept these fossils in exceptional condition, with some even retaining fur, skin, tendons, and soft tissues, a rarity that offers unparalleled research opportunities. Among the most notable finds were near-complete woolly mammoth skeletons with preserved patches of coarse brown fur. These remains offer insights into the mammoth's diet, migration patterns, and how they adapted to the extreme cold. One particularly striking discovery was a juvenile mammoth, its body so well preserved that scientists could analyze its stomach contents, which revealed a diet of grasses, sedges, and wildflowers. This kind of information helps researchers understand not only the behavior of these Ice Age giants, but also the flora and environmental conditions of their time. Steppe bison remains were another major component of the find. Known for their large horns and robust bodies, these ancient bison played a key role in the ecosystem, grazing on the tundra vegetation and supporting predators like dire wolves and saber-toothed cats. The discovery of bison skeletons with preserved ligaments and fur allows for detailed anatomical studies and comparison with their modern descendants. Additionally, fossilized wolf remains, including bones and teeth, provide clues about the predator-prey dynamics of the time. The genetic material preserved in these specimens is of particular interest to scientists studying ancient DNA. By extracting and sequencing DNA from these fossils, researchers can explore the evolutionary history of these species and their adaptations to glacial environments. This research also contributes to ongoing discussions about de-extinction, the possibility of resurrecting extinct species like the woolly mammoth through genetic engineering. The discovery comes at a time when climate change is causing permafrost to thaw at an accelerated rate, exposing more Ice Age fossils than ever before. While this offers exciting opportunities for paleontological research, it also raises urgent concerns. The thawing permafrost not only risks the loss of these ancient specimens due to rapid decay, but also releases trapped greenhouse gases like methane and carbon dioxide, contributing to global warming. Could future thawing unveil even more spectacular finds, such as complete specimens or entirely new species? Researchers believe the Yukon's permafrost holds countless secrets of the Ice Age, including the potential to uncover how these megafauna coexisted with early humans. As excavations continue, collaboration between scientists, indigenous communities, and miners is crucial to preserving these remarkable windows into our planet's ancient past. The frozen depths of the Yukon remain a treasure chest of prehistoric life, offering endless possibilities for discovery and learning. Meteorite impact crater in Northwest Territories. In 2023, scientists confirmed the discovery of a colossal meteorite impact crater in the remote Northwest Territories of Canada. This 31-kilometer-wide structure, buried beneath layers of sediment and ice, was identified using a combination of satellite imagery, aerial surveys, and ground-penetrating radar. Estimated to be around 400 million years old, the crater dates back to the Devonian period, a time when Earth's seas were teeming with early marine life, and the first primitive forests were beginning to take root on land. This discovery provides an extraordinary window into both planetary geology and the environmental upheaval that such impacts can trigger. The crater was initially detected through unusual magnetic anomalies in the region, which hinted at the presence of heavily shocked and altered rock beneath the surface. Follow-up drilling confirmed the presence of shocked quartz, fractured bedrock, and melt glass, hallmarks of high-energy impacts. The crater's immense size suggests that the meteorite responsible was likely several kilometers in diameter, striking the Earth with a force equivalent to millions of nuclear bombs. The resulting explosion would have vaporized rock, ignited wildfires, and triggered massive tsunamis, reshaping the land for hundreds of kilometers around. The environmental effects of this impact were catastrophic. The collision likely released vast amounts of dust and aerosols into the atmosphere, leading to a temporary cooling period known as an impact winter. This cooling could have disrupted marine ecosystems, causing significant extinction events and altering the course of evolutionary history. Given the Devonian period's rich biodiversity, including early fish, coral reefs, and the first amphibians, the crater may hold clues about how life adapted to sudden and extreme environmental changes. Scientists are now analyzing rock cores extracted from the crater to better understand the sequence of events following the impact. These cores contain layers of melted rock and sediment deposited shortly after the collision, offering a detailed record of the aftermath. The chemical composition of these layers can reveal insights into the atmosphere's composition, the presence of greenhouse gases, and the climate changes that occurred in the wake of the impact. This discovery also deepens our understanding of the frequency and consequences of large impacts on Earth. By comparing this crater with others around the world, scientists hope to refine models of how meteorite strikes have influenced the planet's geological and biological history. The crater's location in a remote and largely unexplored region raises the possibility that more ancient impact sites remain hidden beneath Canada's vast wilderness. Ongoing research aims to map the full extent of the crater and investigate whether the impact influenced regional tectonic activity or left traces in the fossil record. Could this impact have contributed to one of the minor extinction events of the Devonian period? Future studies using advanced imaging technologies and isotopic dating may provide answers to these questions. As scientists continue to explore Canada's remote landscapes, the potential for discovering additional craters or other cosmic relics remains high. Each new find adds to our understanding of Earth's dynamic past and the role extraterrestrial events have played in shaping the planet we know today. The vast, untamed wilderness of the Northwest Territories still holds many secrets, waiting to reveal the hidden story of our planet's violent and fascinating history. New volcanic field discovered in British Columbia. In 2024, geologists made an extraordinary discovery in northern British Columbia. An ancient volcanic field concealed beneath dense forests, glacial sediments, and rugged terrain. This volcanic field, estimated to be over 10 million years old, consists of a network of lava domes, fissures, basalt flows, and pyroclastic deposits. The discovery was facilitated by state-of-the-art technologies, including LiDAR, light detection and ranging, scanning, aerial surveys, and radiometric dating, which allowed scientists to map the extent and composition of the volcanic features hidden beneath the surface. The volcanic field likely formed during the Miocene epoch when intense tectonic activity characterized Western Canada. The subduction of the Pacific Plate beneath the North American Plate created conditions conducive to volcanic activity, resulting in repeated eruptions over a span of several million years. The newly discovered field adds to the understanding of the tectonic forces that have shaped the Pacific Northwest and highlights how dynamic and volatile the region's geological history has been. Researchers identified numerous lava domes, which are mounds formed by the slow extrusion of viscous lava. These domes are surrounded by pyroclastic deposits, indicating explosive eruptions that sent clouds of ash, gas, and volcanic rock into the atmosphere. Fissures crisscross the region, marking the paths where molten magma once surged to the surface. Basalt flows, some extending for kilometers, suggest that certain eruptions were highly effusive, spreading lava across vast areas before cooling and solidifying. The discovery has significant implications for understanding Western Canada's geothermal potential. The ancient volcanic system may still retain heat deep underground, creating the possibility for geothermal energy extraction. Geothermal energy is a renewable, sustainable resource that could provide clean power to remote communities, reducing reliance on fossil fuels. Researchers are now investigating whether hot springs or underground reservoirs of heated water are present, which could be harnessed for geothermal energy projects. In addition to its energy potential, the volcanic field provides clues about the region's seismic hazards. Though the field is considered dormant, the presence of ancient fissures and magma chambers raises questions about the potential for renewed volcanic activity. Scientists are using seismic surveys and thermal imaging to detect signs of active magma movement or heat anomalies beneath the surface. Understanding these risks is crucial for preparing communities and infrastructure in case of future volcanic events. This discovery also sheds light on the region's mineral wealth. Ancient volcanic activity often brings valuable minerals to the surface, such as gold, copper, and rare earth elements. Exploratory drilling in the area has already hinted at deposits that could have economic significance, potentially attracting interest from the mining industry. Moreover, the volcanic field opens new avenues for scientific research. By studying the composition of the lava and pyroclastic rocks, geologists can reconstruct the conditions that led to the eruptions and learn more about the Earth's mantle beneath this region. This research contributes to global models of volcanic activity and plate tectonics, enhancing our understanding of how volcanic fields form and evolve. The remote location of this volcanic field means that large parts of it remain unexplored. Future expeditions, equipped with advanced drones, satellite imaging, and geochemical analysis tools, are likely to uncover more hidden features. Could there be additional undiscovered volcanic systems in this region waiting to reveal their secrets? The ongoing exploration of northern British Columbia promises to deepen our knowledge of Canada's fiery geological past and its potential for future discoveries. Biodiversity in underground British Columbia. Off the coast of British Columbia, marine biologists made a remarkable discovery in 2024, uncovering new deep-sea species thriving in hydrothermal vents. Using remotely operated vehicles, ROVs, researchers captured footage of previously unknown tubeworms, crabs, snails, and sea anemones. These organisms survive in extreme conditions, including high pressures, toxic chemicals, and temperatures over 300 degrees Celsius, relying on chemosynthesis instead of sunlight for energy. This discovery offers insights into life's adaptability and the origins of life on Earth. Scientists are excited about the potential biomed applications of these organisms, as they produce unique enzymes and compounds that could inspire new medicines. Continued exploration could reveal even more groundbreaking biodiversity and help address conservation needs. Giant dinosaur discovery in Alberta. In 2023, paleontologists in Alberta's Dinosaur Provincial Park unearthed the fossilized remains of a new species of giant dinosaur that roamed the region 75 million years ago. The discovery included a nearly complete skeleton, providing insights into its anatomy, social behavior, and potential migratory patterns. The remarkably preserved bones suggest the hadrosaur lived in herds, grazing on lush vegetation that thrived in the ancient floodplains. Alberta's rich fossil beds continue to reveal new species, helping scientists piece together the diverse ecosystems of prehistoric North America. Could more dinosaur fossils still lie hidden beneath Canada's Badlands, waiting to reshape our understanding of ancient life? With ongoing excavations, each new discovery deepens our knowledge of Earth's distant past. Oldest pine tree fossils found in Nova Scotia. In late 2023, paleobotanists discovered fossilized remains of ancient pine trees in Nova Scotia, estimated to be 350 million years old. These fossils, dating back to the Carboniferous period, represent some of the oldest examples of coniferous trees ever found. The discovery sheds light on the early evolution of forests, highlighting how these primitive trees adapted to Earth's changing climate and helped shape terrestrial ecosystems. The fossils' exceptional preservation, including pine cones, needles, and even bark impressions, allows researchers to examine intricate details of their structure and reproductive systems. This discovery reveals how early conifers played a pivotal role in stabilizing soils, reducing atmospheric carbon dioxide, and creating habitat for emerging animal species. Additionally, studying these ancient plants provides insight into how modern trees may respond to current climate challenges. The find raises the tantalizing possibility that more fossilized forests lie buried beneath Canada's landscapes, waiting to be unearthed. Each new discovery enriches our understanding of Earth's green past and the evolution of life on land. Ice patch archaeology in the Canadian Rockies. Climate change-induced melting in the Canadian Rockies has exposed ancient artifacts preserved in ice patches for thousands of years. In 2024, archaeologists discovered a collection of hunting tools, such as wooden shafts, stone arrowheads, and animal remains, dating back over 6,000 years. These finds offer unprecedented insights into the lives of indigenous hunters who navigated these rugged landscapes. The melting ice continues to reveal more relics, but it also underscores the urgency to preserve and document these artifacts before they deteriorate. New plant species in Quebec's boreal forest. In 2023, botanists exploring Quebec's boreal forests identified a new species of moss, Bryum caenis. This moss, thriving in nutrient-poor soils, demonstrates remarkable resilience to extreme temperatures. The discovery highlights the rich yet underexplored biodiversity of Canada's boreal regions. Further studies of this new species may reveal clues about plant adaptation to climate change. Could there be more undiscovered plants within Canada's vast forests waiting to provide solutions to modern environmental challenges? Future discoveries await. From Viking explorers and Ice Age giants to volcanic fields and ancient forests, Canada remains a land of endless mysteries. As technology advances, who knows what more this vast and diverse country will reveal? Stay curious, and the Great White North might surprise you with its next astonishing discovery.